In this video, we will discuss the fence method, which is what I call it, but the formal term for it is dimensional analysis. And all that is again a fancy name for unit conversions, which you will do a lot in chemistry. And a good strategy with any chemistry problem that I would get in the habit of, and I've seen a lot of students that when they do this, they just are more likely to do well, and that is to underline what you are given and then to circle what you are trying to find. And so we just said that we're going to circle what we're trying to find, underline what we're given. And then what we're going to do is we're going to write the value given in the unit that we're also given with it. And then we want to kind of think of a way that gets us closer to our desired unit. And then we need to start canceling units. And so one thing that's important to understand is that if I take 5 and I divide it by 5, that gives me 1. Those 5s cancel. Okay? What's also the same is that if I take grams and I divide it by grams, I have now canceled grams and I get 1. And so we're going to be able to cancel units that way. So I'm going to jump around, and I wish after looking at this I would have put my problems in a different order, but it's too late for that. And I'm going to start on number 10 because we use normal units. In a couple problems we're going to need to be able to use our metric prefixes, and we definitely need to know those for dimensional analysis or the fence method. Okay, so what we're going to do is we're going to do our first step, and that is underline what we're given. So we're given 3.4 days, and we need to convert that into seconds. And I'm sure that you can do that in your head, but I don't know that most people can do it in a way where they can show their work clearly. Anyone who is reading it can kind of understand what's going on, and that's where we need to be able to do this, because we're eventually going to get into units and numbers that maybe don't make sense to do in our head because they're very abstract or very tedious, and so we could lose track of numbers. And so what I'm going to do is I'm going to write what I'm given, 3.4, and I always need to put a unit on my numbers while I'm converting. Okay, so 3.4 days. And what I want to do is I want to get days closer to seconds. I don't know how many seconds are in a day. And so what I do know is hours. I know how many hours are in a day. So what I'm going to do is, this is why it's called the fence method, is I'm going to just build a little fence. And let's pause here really quickly and just show you what the fence represents. If I have 5, and I'm going to exclude units, I'm going to break that rule even though I shouldn't. And then I have 1 here and 7 here. What this is telling me is 5 times 7 divided by 1. So that would be 35. If I had, let's change this to a 3. This would be 5 times 7 divided by 3, whatever that would be. Okay, now what if the fence was a little bit bigger? This would be 5 times 7 times 2, so that'd be 70. Actually, let me do it all in one step. And then divided by 3, that'd be 70 divided by 3, whatever that number is. What a lot of people will goof up on is, what if there's what if there's a 4 there? This would be 5 times 7 times 2 divided by 3 divided by 4. Okay, so this is the same thing as 5 times 7 times 2 over 3 times 4. 5 times 7, this would be 70 twelfths. Okay, And you'll get better at that. It's a little bit strange at first. It's just a way of writing fractions. So what I'm going to do is I need days to cancel. So I'm going to put days in the denominator over here. And what that allows me to do is when I do my math, because one's in the numerator and one's in the denominator, I will end up taking days divided by days, and that gives me 1, so that essentially cancels that unit. We said we're going to go from days to hours. So now I need to think about how many days are in an hour, and I don't know that answer, but I know the opposite of it, or the reciprocal. I know that 1 day is 24 hours. Okay, so now my days have canceled and my unit is hour, but that's not where I want to be. I've circled seconds, so I need to continue this, and I just need to convert hours now. I know I need to put hours in the denominator because hours divided by hours will be 1, and that unit will cancel. And I'm going to go from hours to maybe minutes. I don't know how many hours are in a minute, but I know how many minutes are in an hour. And so I'm going to do 60 minutes for every 1 hour. And my hours cancel. And I'm at minutes. So now I'm going to do minutes. And I'm going to convert minutes to seconds, and that's my desired unit. And I don't know how many minutes are in a second, but I know how many seconds are in a minute. And so what I'm going to end up with here is my minutes have canceled. I'm going to get 3.4 times 24 times 60 times 60. I've hit my numerator. Now I have all these ones in my denominator, which will mathematically not change anything, but I'm going to write them down because they're not always 1. 1 can be in the numerator, it can be in the denominator, it's not stuck anywhere. And when I plug this into my calculator, I get 2.9376 times 10 to the 5th, but I need to put units on it. And the only unit left that did not get canceled was seconds, so it must be seconds, which makes sense because that's what I was solving for. That's where this is going to go, but in units that maybe are a little bit less familiar to us. So let's go back and we'll start with number 1 and we'll just do some examples. It says we have 1 liter. It wants to know how many milliliters. So I'm going to write down 1.0 liters. And liters is a base unit. And the thing that's nice is that when you have a base unit, you can go from the base to anywhere in one step. So what I'm going to do is I'm going to put liters here and milliliters here. And with this picture, these numbers are always the exponential factor for the base unit. Okay, so if I'm going from liters to milliliters, that's right here, I need 10 to the minus third for liters, and your thing that has a prefix can have a 1. Okay. Now, some people would say, and let me solve this out, I'm going to take 1, or let me do that a little bit better, 1.0 times 1 divided by 10 to the minus third. When you do that, you get 1 times 10 to the third. What some people would say is, well, I know that there's 1,000 milliliters in a liter, so 1 liter. In 1 liter, there's 1,000 milliliters, and you would get 1,000 milliliters as well. Okay, so both ways are just fine. And number 2 says, how many grams are equal to 52.8 kilograms? So I'm given 52.8 kilograms, and I need to get to grams. I'm at kilograms. I need to put kilograms in the denominator, so it cancels, and I'm going to go to grams. Kilograms has a prefix, kilo, so I'm going to put a 1 there. And then what I'm going to do is I'm going to find the kilo, and it looks like it's 10 to the third, so that would be 1,000 grams. And so when I math this out, I'm going to get 5.28 times 10 to the fourth grams. Okay, let's do some more tricky ones. Let's do number 9. It says how many micrometers, so we need to circle that, are in 8,956 kilometers. So micrometers, that's this symbol. Kilometers is here. Well, if I don't know how to do this, I at least know how to start it with my rules. And so I'm going to say we have 8,956 kilometers. I know kilometers will go down here. And here's what I'd like you to do. You don't have to do it this way, but this is... and I've pasted my metric prefixes above it, but on yours you should be able to see this. It says if you're going from prefix to prefix, please travel through the base unit. Now, if you know exactly how to go from micrometers to kilometers because you have that memorized, feel free to do that, but it needs to be correct. The way I'm teaching it would allow anybody to just memorize their metric prefixes from this chart and not anything more and still be able to do this. So what I'm going to do is micrometers and kilometers both have prefixes, so I know I'm going from prefix to prefix. So I'm asking you to travel through the base unit, so we will do that. Kilometers has a prefix, so we'll put a 1 there. And then in 1 kilometer, that's 10 to the third meters according to my metric prefixes. And the meters needs to go down here in order for meters to cancel. And then I'll go to micrometers. Micrometers has a prefix, so I'll put a 1 there. And then the number for micro would be 10 to the minus 6. And so when I solve this in my calculator, I'm going to do 8,956 times 10 to the third times 1 divided by 1 divided by 10 to the minus 6. And that gives me 8.956 times 10 to the 12th, or 8.956 trillion micrometers. That's a very large number. But that number kind of makes sense because micrometers are really small, kilometers are really big. So if I want to know how many micrometers are in a kilometer, I should expect a lot.